Okay, so to continue, so we have here temp assigned with blocks plus 2, then dereference it. So since the value of blocks here is the address of the first element of the array, which is 4434, then you add 2 offsets, you will get the address 4436. Then dereference it, meaning we get the value located at address 4436, which is C. So the new value of temp now will be C. Okay, then the next one here is we assign temp with PTR plus 1 offset, then dereference it. So since the value of PTR earlier is 4434, then you add 1 offset, you'll get the address 4435. Then using a dereference operator, we get the value located at address 4435, and that's B. So the new value of temp will become B. Then we assign temp with the value pointed by PTR. So since the value of this address stored in PTR is still 4434, then we dereference it. We get the value located at address 4434, and that's A. So the value of temp now is A. Then we assign PTR with blocks plus 1. Okay, so again, since the value of blocks is 4434, since it's the address of the first element of the array, plus 1 offset, you'll get the address 4435. So the new value of PTR is 4435. Then we assign temp with the value pointed by PTR. So since the value of PTR now is 4435, then we dereference it by getting the value at address 4435, and that's B. So B becomes the new value of temp. Then we assign temp again with PTR plus 1, then dereference it. So since PTR is 4435 plus 1 offset, you'll get the address 4436. Then dereference it, so the value located at address 4436 is C, and it's the value of temp. Then we assign PTR again with blocks. So PTR now becomes 4434. Okay, it becomes back to 4434. Then here in temp, we use 2 operators here, the increment operator and the dereferencing operator. What is executed first here is the increment operator. So if PTR is 4434, we increment it by 1, so PTR now becomes 4435. And then we dereference it, we get the value at address 4435, which is B, and B becomes the new value of temp. Okay, so whereas here, we still have 2 operators, the increment operator and the dereferencing operator. Okay, so what we're gonna do here is get the value of PTR, which is 4435. Okay, dereference that, so the value at address 4435 is B, then we increment B by 1. So meaning to say, in the ASCII ordering, we add 1 character code to B. So what follows B is C, so the new value of temp is C. Now, for example, if the value of blocks is A, B, and M, so the value of temp here will not be M, but it will still be C, because in ASCII ordering, C always follows B and not M. Okay, so whereas here, what happens here is we increment PTR first. Okay, so if PTR is 4435, we increment it by 1, so PTR becomes 4436, and then we dereference it. Okay, so we get the value located at address 4436, which is C, and C will become the new value of temp. Then lastly, we assign temp with the value pointed by PTR. So since PTR is 4436 and the value that it points is C, so the last value of temp will be C. Okay, so as you can see here, there's a mixture of array indexing and pointer arithmetic and the way we access the elements of the array. Okay, so the question now is, when is array indexing better to use than pointer arithmetic and vice versa? Okay, or what are the trade-offs of using array indexing and pointer arithmetic? Okay, so if the array is to be accessed sequentially, then pointer arithmetic is better and faster because you can just simply use the increment and decrement operators with pointers, and it works faster. Okay, whereas if you access the array in random order, then array indexing is faster because you can just supply specified index and automatically it will access the element located at that index. Okay, so again, if the array is to be accessed sequentially, pointer arithmetic is better and faster, but if the array is to be accessed randomly, array indexing is better and faster. Okay, so let's discuss arrays of pointers. So in many cases, it is useful to declare an array of pointers and access the contents pointed to by the array by dereferencing each pointer. Okay, so meaning to say, you're not only limited to array of integers or array of characters or array of floats or array of doubles and the like, but you can also have an array of pointers. So for example, here we have an array of pointers to integer, which is ptrint with size 3. So it will have 3 cells, and all the 3 cells will contain addresses of variables of type int. Okay, then you have here 3 integer variables initialized to 10, 100, and 1000 respectively. Okay, then the next assignment statements here, ptrint index 0 will be assigned the address of x1, and ptrint 1 will be assigned the address of x2, and ptrint index 2 will be assigned the address of x3. So the contents of index 0, 1, and 2 are the addresses of x1, x2, and x3. So if you want to display these values 10, 100, and 1000 through the pointers, okay, then we can just simply use a for loop such as this and use a dereferencing operator and an index. So first iteration here, it will print the value pointed by the address located in ptrint index 0. Then the next iteration, so I becomes 1, so it will dereference the value located at address ptrint index 1, and so on. So this is how it looks like. Okay, so you have here an array of pointers to integers with 3 elements. Okay, and you have your 3 variables here. So let's make an assumption that x1 is located at memory address 600, x2 is at memory address 700, and x3 at memory address 800. Okay, so executing these assignment statements, index 0 will contain the address of x1, so it will be pointing to x1. Index 1 will contain the address 700, so it will point to x2, and index 2 will contain the address 800 and it will be pointing to x3. So if you want to print 100 using the pointer here, then you can just simply use a simple printf statement. For example, okay, you can write your printf statement here. So you will use %d since it's an integer, and use the dereferencing operator, then the name of the array, and the index, which is index 1. So if we trace this, okay, so the address located in ptrint index 1 is 700. Okay, and using the dereferencing operator, it will access the value located at address 700, which is 100. So it will display here the value 100